In this next video, we're going to continue with simplifying polynomial expressions, but now we're going to multiply polynomials. When you're multiplying, the main thing that you're going to do is distribute. So here in example 1, I'm going to distribute 4x times 3x squared. Now here I'm going to put an imaginary exponent of 1. Now I'm going to make a little note. Remember, when you multiply, you add exponents. And this is something we learned when we went over the laws of exponents. So here, make sure when you're multiplying, you add the little exponents to each other. So 4 times 3 is 12. And for the x's, you would add 1 plus 2. And that gives you 3. Then I have 4x times negative 5. 4 times negative 5 is negative 20. And I could just bring that x there. So this would be my expression because those are not like terms. On question 2, I'm going to do 7a cubed times 6. That's going to be 42a to the third. Then I'm doing 7a cubed times negative 2a. 7 times negative 2 is negative 14. Here I'm going to put an imaginary 1. So when I do the a's, I'm doing 3 plus 1. So that comes out to a to the fourth. Now if I do 7 times negative 1, that's negative 7. If I combine those a's though, now I'm doing a cubed times a squared. So I'm adding 3 and 2. So I get a to the fifth. So when you multiply, you add those little exponents. None of these are like terms, so I can leave my answer written in this form. Question 3 is also a multiplication problem. Here, though, we're going to have to distribute several times. So I'm going to start by distributing the 2x to everything. So I'm going to do 2x times 3x. That comes out to 6x squared. Then I'm going to do 2x times 7, which is 14x. Now I'm going to distribute the negative 2 to everything. So I'm going to do negative 2 times 3x, which is negative 6x, and then negative 2 times 7, which is negative 14. So I just distributed the 2x and then the negative 2. Remember, you're always using the signs that are in front when you distribute. Now, from here, I'm going to combine like terms. So 6x squared doesn't have a like term, so I'm going to leave that 6x squared. But here you can combine 14x minus 6x because those are like terms. So you combine those, you get 8x, and then I'm going to bring down that minus 14. I didn't have to rewrite this one because the like terms were already next to each other. Now in question 4, this one's a little different. They're writing it squared. Well, to square something means to multiply it times itself. It's like if you had 3 squared, you'd really be doing 3 times 3. So here 2a minus 6 squared means you're doing 2a minus 6 times 2a minus 6. So I'm going to start distributing. So if I do 2a times 2a, that gives me 4a squared. Because remember, you're adding your exponents. And then if you do 2a times negative 6, you get negative 12a. Next, I'm going to distribute the negative 6 times everything. So negative 6 times 2a is negative 12a. And negative 6 times negative 6 is positive 36. From there, I'm going to try to combine like terms. So there's no other a squared, so I'm going to leave 4a squared alone. But I can combine negative 12a with negative 12a. That would be negative 24a. And I'm going to bring down the 36. So to summarize, when you're squaring something, you're just multiplying it times itself. So you want to rewrite that problem. In these last problems, we're continuing with distributing, but it's going to get a little bigger. So here we have 2n squared times n squared. That's going to be 2n to the fourth. Because remember, when you multiply, you add exponents. So 2 plus 2 is 4. Next, I'm going to do 2n squared times negative 5. That's negative 10n squared. Now I'm going to distribute the negative 3 to the n squared. That's negative 3n squared. And then I'm going to distribute negative 3 times negative 5, which is a positive 15. From here, I'm going to check for like terms. So there's no other n to the fourth, so that stays the same. I can combine negative 10n squared with negative 3n squared. That's negative 13n squared. And I'll bring down my 15. Now in question 6, it's the same thing. We just have an extra term on that second parentheses. So I'm going to multiply the x times everything. I'm going to put an imaginary 1 here so that when we multiply, we remember to add the exponents. So x to the 1 times x squared is x cubed. X to the 1 times negative 3xy would be negative 3. Here, since there's another x, if you add those exponents, it becomes x squared. And then you would write your y at the end. And then x times 4y squared would be 4. Since those letters are different, you just put them together. So I'm going to combine the x with the y squared. Next, I'm going to distribute the negative 3y to the x squared. So I have negative 3. Since those are different letters, we just put them together. We usually put the x before the y. So I have 3x squared y. I'm going to multiply that times negative 3xy. So negative 3 times negative 3 is positive 9. And then there I would write my x. And I have a y times a y. So if you multiply those, you get y squared. And then the last thing we would multiply here would be negative 3y times 4y squared. So negative 3 times 4 is negative 12. And then y times y squared is going to be y to the third power, because 1 plus 2 is 3. Let me rewrite this just so everything's right next to each other. Okay, so now that we've distributed everything, we're going to combine like terms. So I'm going to start with x cubed. There is no other x cubed, so that one stays the same. Next, I have negative 3x squared y. So I'm going to look for another x squared y. Here I have another negative 3x squared y. So I have x cubed, and these, if I combine them, I get negative 6x squared y. When you're combining like terms, the exponents don't change. So when you multiply, you add exponents, but when you're combining them together, you leave them alone. Next, I'm going to combine 4xy squared with 9xy squared. That will combine to give me 13xy squared. And then the minus 12y cubed doesn't have a like term, so it stays by itself at the end. So there I just combined the like terms. When I was done, they have to have the exact same letters to the exact same exponents to be considered like terms.